Hello children, warmly welcome to Guru Gedara educational program. As usual, today also I am going to teach you another important lesson in grade 11 science syllabus. You can remember earlier we studied about electronics. Today I am going to teach you the second lesson of the unit electronics. My dear children, I think you can remember we learn about electronic appliances that we use in our day-to-day life. After that we learn about what are semiconductors, intrinsic semiconductors, extrinsic semiconductors, p-n junction and also the diode. I hope you can remember the function of a diode. What is the function of the diode? The diode is an electronic device which allows the electricity to flow only in one direction. We studied about the variation of voltage over time, variation of voltage of direct current over time, and also variation of alternating current over time. You can remember. This shows you the variation of voltage of a direct current with time. It is parallel to the time axis. It is a straight line. When you think about the variation of voltage of an alternating current with time, you can see it varies as a sinusoidal wave. Voltage, time, the variation can be seen. Right. Now, let's do a simple activity to find out the changes that takes place when connecting an AC current to a diode. Why do I say so? You can remember diode is an electronic device which allows the electricity to flow towards one direction only. And you can remember dynamo is a device which generates an alternating current. Now I am going to connect the alternating current dynamo to a diode. Then we can observe the changes takes place in the direction of current. Let's do this activity. Now, as you can see, this is the structure of a dynamo and these are the connecting wires, and here I have connected a diode here. You can see a diode is here, right. So, earlier what happened, you can remember when operating the dynamo, the galvanometer deflects to either directions, either sides. Now you can watch the galvanometer deflects only to right direction. What has happened here? The main reason is the diode allows the electricity to flow only in one direction, right. Let's connect this galvanometer to the AC supply, alternating current supply, right. I have connected the transformer to the main power supply which gives alternating current, 50 hertz of frequency, 230 volts. Now, you can see when connecting the, you can see the deflection of the galvanometer. The galvanometer indicator deflects to either sides rapidly. Why is that? That is because of the alternating current produces by the transformer. Here we use a transformer to reduce the 230 higher voltage into 12 volts of lesser voltage. Right. Now I am going to connect a diode in between the transformer and the galvanometer, and let's learn what changes takes place when connecting a diode before passing the current to the galvanometer. Right. This is the prepared diode. Here you can see the direction of the arrowhead. I am going to connect positive terminal to the positive side. Now you can watch that the galvanometer indicator deflects rapidly, but only towards one side. It is towards the left side. Through this simple activity, you can understand diode is an electronic device which allows the electricity to flow towards one direction only. Now if we change the terminals of the diode, let's change. We use another diode which is arranged in the opposite direction. Right. In the previous instance, it deflects to the left side. Now let's focus our attention the second instance. Now you can see in this instance the galvanometer indicator deflects towards the right side. That is because of the change in the diode direction. Right. My dear children, you could realize the main function of the diode. What is that? Diode is an electronic appliance which converts an alternating current into a direct current, because diode allows only one half of the alternating current to flow through the circuit. Let's learn more information regarding the process done by diode. What is the reason for having that change? The diode allows the electricity to flow only in one direction, and as a result, it converts the alternating current or AC current into a direct current. Right. So, how do we call for this process? My dear children, we call this process as rectification of an alternating current. How do you call? Rectification of an alternating current. Right. What is rectification? Rectification is the process of converting an alternating current into a direct current that flows only in one direction. Because you can remember at the beginning we studied that alternating current is a current that alternates the direction 50 times per second. but direct current is a current that flows only in one direction, that means from positive terminal to negative terminal. I am going to ask you some questions. What are the instruments that produce DC current? Dry cell, solar cells, those are the sources of electricity that produce a direct current. My second question, can you remember what are the devices that generate an alternating current? As we did, bicycle dynamo, generator, those are the devices that produce alternating current. Right. As I told you, rectification means the process of converting an alternating current into a direct current. Do you know? There are two forms of rectification. What are they? Half wave rectification and full wave rectification. Half wave rectification and full wave rectification. Right. What is called as half wave rectification? Can you remember when plotting a graph for the alternating current, voltage across time, there were sinusoidal waves. Sinusoidal waves. That wave consists of two halves, positive half and negative half. Here, in half wave rectification, what do? We convert only one half of the positive half or negative half. So we can say the process of converting only one half of a cycle of an AC current into a DC current. Then what is full wave rectification? Full wave. AC wave consists of positive half as well as negative half. In full wave rectification, what do? We convert not only one half, we convert both the halves of the alternating current into a direct current. So, we can understand full wave rectification means the process of converting both the halves of a cycle of an AC current into a direct current. We can study how does this take place through simple activities. First of all, let's focus our attention on half wave rectification. Right. As you can see, this is the circuit that we have to arrange for the process of half wave rectification. Half wave rectification is done by connecting a diode to a circuit that carries an alternating current. Can you remember, my dear children, what did we do earlier? We connected a diode to the dynamo. In that instance, what happened? The galvanometer indicator deflects only to one direction. When there is no diode, when we connect the galvanometer to a dynamo, in that instance what happened? The galvanometer indicator deflects to both directions. That's the difference. That means what has happened really? What has happened really is conversion of alternating current into a direct current. You can see here, this shows graphical representation of alternating current input. As I told you earlier, it consists of positive half, negative half, positive half, negative half. This sinusoidal wave consists of alternate positive halves and negative halves. Then we connect the AC input into a transformer. You will learn about transformer in coming lessons. Here we use a step down transformer. You can watch, this is also a step down transformer. We use this step down transformer to convert a higher voltage into a lower voltage. Right. That is why we call it as a step down transformer. This diagram shows you the symbol of step down transformer. After that, current passes through that. Can you remember, my dear children, what is this symbol? Yes, I am sure you can remember, this is the symbol of a diode. So AC current passes through the diode. Then this is the resistive load. Here we can use a resistor, if not a bulb or whatever the appliance operated by electricity. Then what happens? Sinusoidal wave of the input AC current passes through the step down transformer to convert the higher voltage, that means 230 voltage, into 12 volts or 6 volts lower voltage, and it passes through the diode. Then what happens? When it passes through diode, diode allows only one half of these halves to pass through it. So only positive half of the AC current may pass through the diode. The negative half will not pass through the diode. That means we can obtain output voltage as shown in this graph. Only positive halves are there. Negative halves are not there because diode did not allow the negative halves of the AC current to pass through them. Right. We can observe this process using an instrument called cathode ray oscilloscope. I am going to show you how does this conversion of AC into DC takes place with the help of cathode ray oscilloscope. First of all, I am going to connect the transformer to the main power supply. Then I am going to connect the transformer to the diode. This is the diode here. Then I am going to connect the load or the resistor. As the load or the resistor, I used a bulb here because you know the filament bulb consists of a resistor. Now I am going to connect positive to positive. Now, first of all, you can draw the attention on the cathode ray oscilloscope. Here, a straight line can be seen. Straight line can be seen. and also you can watch bulb glows. Bulb is glowing. Right. What does that mean? Current passes through the circuit. Step down transformer converts the higher voltage into lower voltage. Then it passes through a diode. After that, it passes through the load or resistor or the bulb. Now I am going to connect this. Before connecting that, I would like to say you something. The cathode ray oscilloscope is a very sensitive instrument which can sense the current that generates within our body. Now you can see when I am going to touch this, a change takes place here. Here. Why is that? That is because of the very small induced current generated within the human body. This can sense only by a cathode ray oscilloscope. You can see the difference when I touch the needle. Right. Now, my dear children, I am going to show you the rectification. Now you can see that although it is better, first of all I will show you the AC voltage before connecting the diode. Now first of all you can watch the AC voltage here. Can you see that? AC voltage vary with the time as a sinusoidal wave. That is because of the alternation of the direction of current with time. Now I am going to connect the diode. We can say this diode as a rectifier diode because diode is an instrument or an appliance that converts the AC current into a DC current. Now here you can see that when connecting the diode, the brightness of the bulb also reduces. Why is that? In the previous instance, more current passes through the circuit, but when connecting the diode, only 1/2 of the AC current passes through the diode. That means the power of the electricity has been reduced. Now you can see the half wave rectification. Only 1/2 of the AC current passes through the diode. This is called as half wave rectification. Here only the positive half can be seen. Now, my dear children, I am going to show you how to connect the diode in opposite way. First of all, I would like to show you the two setups where I arrange the diodes. By looking at these two structures, you can see the different directions of arranging diodes. In the previous one, diode is arranged to one side. In the second structure, diode is arranged to the opposite side. Earlier, I showed you the half wave rectification using the first diode. Now I am going to show you the half wave rectification using the second diode which is arranged in the opposite direction. Then you can watch the difference of the half wave rectification. This is the diode arranged in the opposite way. In this instance also you can see the brightness of the bulb reduces. Now you can see only the negative half will be rectified. In the previous instance, only the positive half of the AC current rectified. Here, only the negative half of the AC current rectifies. Alright children, we engage in the activity to study the half wave rectification using both sides of the diode. Then for further investigation, you can watch this video to understand the things more clearly. You can watch when the positive negative changes, AC current direction changes. Here this graph represents the variation of alternating current with time. Here positive negative changes, but when we connect the diode, positive to positive we call forward bias, current passes, but negative to positive current does not pass through the diode, because diode allows the electricity to flow only in one direction. So we can say diode as a rectifier because it converts AC into DC. This is the circuit diagram we arranged: AC supply, step down transformer, diode, resistive load. Here we used a bulb, right? When the negative positive changes alternately, it becomes positive negative positive negative. The direction also alternates, but here diode allows only the positive half to pass through that. You can watch, positive half passes, negative half does not pass through the diode. Again positive half passes through the diode. Right, my dear children, let's focus our attention on the full wave rectification. Right, this is the circuit diagram that we arrange for full wave rectification. Here we use AC power supply, step down transformer, rectifier bridge, and load, a bulb or resistor. Right. How to make the rectifier bridge? I am going to show you it briefly, little by little. First of all, we have to use 4 diodes, 1, 2, 3 and 4. And we have to arrange these diodes in this manner. 4 diodes, and we connect the 4 diodes in this way. Then we have to arrange the circuit for the full wave rectification in this manner. Right. So when supplying an AC current to a circuit and connecting to a galvanometer, what will happen? Let's see that. I am going to connect full wave rectifier circuit. This shows you the rectifier bridge. This is the rectifier bridge arranged by 4 diodes as shown in this picture. I am going to connect this to the step down transformer. and then I am going to connect this to the center zero galvanometer. Now you can see the galvanometer deflects only to one side. That means the rectifier bridge also used to convert the AC current into DC current. Galvanometer deflects to one side only, but it deflects rapidly. Diode bridge converts the AC current into a DC current. Now, when point A becomes positive, point B becomes negative in the AC current. So, let's learn how current passes through the circuit. A to C, then C to E through the D2 diode, E to X, X to Y, Y to G, G to H, H to F through the D2 diode, and F to B. This is the flow of current. When the A terminal becomes positive, B terminal becomes negative, this is the way of flow of current through the diode bridge. Here we can represent using the letters also. A, C, D, 2, E, X, Y, G, H, D, 3, F and B. Right. This shows the flow of current through the rectifier bridge only when the A becomes positive, B becomes negative. Now let's learn that when point A becomes positive, the current flows only from point X to Y through the galvanometer. Now let's focus our attention when the A becomes negative. Earlier we studied that when the A becomes positive, B becomes negative. In this case, we focus A becomes negative, B becomes positive. Here let's learn how current passes. B to F, blue arrows represent, F to D4 because this is reverse bias, this is forward bias diode, E to X, X to Y. Now you can see the red color arrow represents the direction of flow of current in the previous instance, X to Y. The blue color represents the direction of current in this instance, it is also from X to Y. Here Y to G, G to H. In this case, you know, this is forward bias, as the voltage is higher, current passes towards lower voltage, that means towards direction C across the diode D, and from C to again A. You know that current passes from positive to negative. In this way, you can represent that using letters B, F, D2, E, X, Y, G, H, D1, C and A. Right. That means when point B becomes positive also, the current flows only from point X to Y through galvanometer. What does that mean, my dear children? You can realize in both instances the current flows through the output galvanometer towards one direction only, because the diode bridge converts both the halves of AC current into direct current. This is known as full wave rectification, as it converts not only the positive, not only the negative half, the diode bridge converts both the negative and positive halves of the AC current into direct current. As a result, we call this as full wave rectification. Right. You can see this using the graphical representation. This is the input AC current, consists of positive, negative halves, sinusoidal wave. After the full wave rectification, output DC current, only the direct current can be obtained. Positive half is there, negative half also has been rectified. Now let's compare the half wave rectification and full wave rectification. Right, you can see that the first graph represents the variation of voltage and current over time. In the half wave rectification, only the positive halves there, if not we can say negative halves there, only one of the halves. But here full wave rectification, both negative and positive halves are available as they are rectified by the rectifier bridge. Alright children, now I am going to show you the full wave rectification process using the cathode ray oscilloscope. Right, you can see here as usual I used a step down transformer and also a rectifier bridge diode and load bulb. Now I am going to supply the current here, bulb is glowing. Now you can see the difference. If you can remember, in the previous instance the brightness of the bulb was very low. Why? Only one half of the AC current passes to the bulb. But here in the full wave rectification, as both the halves passes to the bulb, the power is very high. I am going to show you that. Can you see? Both the halves have been rectified, negative half as well as positive halves. This is called as full wave rectification. Right. My dear children, you know that you can remember earlier we studied that diode is also an electronic device which allows the electricity to flow only one direction. So here I have arranged circuit using LEDs because LED is also a diode. This is the rectifier bridge made by using 4 LEDs or diodes. Here you can see the glowing of LEDs. Here draw the attention, only LED in the right side glows here, and here out of these 2 LEDs the first LED glows. Now I am going to change the terminals of the dry cells battery. When changing the terminals, you can understand the difference here. What's the difference? You can see, not like the previous instance, other 2 LEDs are glowing, but in these 2 LEDs, the first LED is glowing. That means, although the terminals change of the power supply, the direction of current through the output is same. That is the full wave rectification. Right. Let's move to the next lesson. My dear children, a half wave or full wave rectification circuit gives out a current flowing in one direction. It's okay. It is a direct current. However, its magnitude or the voltage or current varies between 0 and its maximum value. So it is very important to minimize this variation to operate electronic appliances that we use in our day-to-day life. So how can we minimize this variation? This is done by time variation of the voltage outputs of a battery after half wave and full wave rectification of an alternating current can be seen using this graph. This is the variation of voltage over time from a battery, from a current that you obtain from battery. This is straight line, direct current. This is the variation of voltage of the current with time obtained from the half wave rectification. This shows the full wave rectified current. But you can see this is straight line, smooth flow of current. There is no smooth flow of current. There is a variation between 0 and maximum value. So, how to overcome the variation in half wave and full wave rectification? This is done by smoothing. By connecting a capacitor with a larger capacitance parallel to the output terminals of the circuit, we can obtain this target. The variation in rectified voltage can be reduced. This process is known as smoothing. Have you ever seen a capacitor? Do you know the function of capacitor? This is the diagram of a capacitor. This is the symbol of capacitor. Capacitance of a capacitor is measured by farads. The symbol is capital F. I am going to show you a capacitor. This is a capacitor. Capacitor has two terminals. So, you can identify the function of capacitor. Capacitors are used to store charges temporarily and also to discharge by emitting current. I am going to do a simple activity. These are dry cells. I am going to charge the capacitor. By connecting to the two terminals of the dry cell. I am charging the capacitor here. After charging for about few seconds, I am going to connect the two terminals of the capacitor to the LED. I think you could observe the bulb glows at once and it goes out. That is the function of capacitor, right? So, what is the role of capacitor during the process of smoothing? When the voltage applied by the diode gradually increases from 0, the capacitor gets charged. When the voltage drops back after reaching a maximum value, the charge stored in the capacitor is released. Therefore, the voltage across the capacitor does not drop down to 0, although a small reduction takes place. Now, in addition, because the current flow through a diode is always in one direction only, the discharge current of the capacitor does not flow through the diode. I am going to show you how to smooth the rectified current using the capacitor. This is the circuit diagram. I am going to show you that activity. Here I used, as earlier, transformer, step down transformer, diode, capacitor and load. Now you can watch that. This is the half wave rectified current. Still I didn't connect the capacitor. Now I am going to connect the capacitor. After connecting the capacitor parallelly, you can see the smoothing of half wave rectified current. It is not that much vary as previous instance. Now I am going to connect a rectifier bridge to show you the smoothing of full wave rectified current. You know, this is the rectifier bridge. When I am connecting this rectifier bridge, you can see the full wave rectified current and the smoothing process of it. This is the full wave rectified current. This is the full wave rectified current as we watched earlier. I am going to connect the capacitor here. Now you can see smoothing of full wave rectified current. Right. My dear children, you could study what is half wave rectification, full wave rectification. After that, smoothing of half wave rectified current, smoothing of full wave rectified current. This is the circuit diagram for half wave rectified current, and how do we smooth it? We must connect the capacitor parallel to the output terminals of the circuit. This is how we obtain the graph after the smoothing. Variation minimizers. Circuit for the smoothing of full wave rectified current. AC, step down transformer, rectifier bridge. Here also we have to connect the capacitor parallel to the output terminals. So here this is the wave pattern of the smoothing current after the smoothing. The variation is very much low. Here smoothing becomes better when increasing the capacitance. As I told you, my dear children, capacitance of a capacitor can be measured by using a farad. Right. Let's observe the wave pattern of the half wave rectification, full wave rectification, smoothing of half wave rectified current, smoothing of full wave rectified current using cathode oscilloscope. I think we watched already. Applications of diodes. Where we use diodes, my dear children? A diode allows the electric current to flow only from one direction. So diodes are used for the process of rectification, to prevent the damages caused to the direct current appliances. You can see this is electronic appliance. Positive to positive current flows through that appliance may work, but negative to positive of the diode current does not flow, appliance may not work here. That means we can connect a diode in order to safeguard the safety of electric devices that we use in our day-to-day life. Right. So then let's focus our attention on light emitting diodes. Right. Light emitting diodes differ from size, shape, color and function. I am going to show you a simple activity. We did it earlier also. Light emitting diode. When I keep the positive terminal to positive side, negative terminal negative side, LED glows. That is because of the flow of current. When changing the terminals, it doesn't glow, because you can remember diode allows the electricity to flow only in one direction. Right. Now you know that what are called as LEDs? Are they really bulbs? What do you think about? No, they are not bulbs. They are also diodes which allows the electricity to flow only in one direction. So when a PN junction or diode formed with special semiconductor materials such as gallium arsenide, indium phosphide, and when they are forward bias, light is emitted from the diode. Diodes that are capable of emitting light during the forward bias instance are called as light emitting diodes. My dear children, you can watch the parts of the diodes and the symbol of the diode. Long terminal is the anode, short terminal is the cathode. The flat side is located near the cathode. Anode, the symbol, arrow represents the emitting of light. Arrowhead ends with the cathode. Applications of light emitting diodes. Where we use diodes? Earlier, people used diodes as an indicator. But nowadays, light emitting diodes are used for construction of large television screen, lighting up homes and streets, construction of torches. these are some examples for the applications of diodes that we use in our day-to-day life. Here, color lights, signals, we use diodes. So why do people use diodes? The reasons for the wide usage of LEDs are very low price, very low power consumption, and long lifetime, about 50,000 hours. Why we use LEDs? Again, we can do attention: low maintenance, cost saving, energy saving, long lasting, eco-friendly. Let's focus our attention on final topic of our lesson, solar cells. What are solar cells? Solar cells are also constructed using PN junctions. They are also called as diodes. They are constructed to allow light to fall on the junction. When sunlight is incident on the silicon PN junction, a small electromotive force is generated. As a result, it generates a very small current. But a solar cell produces a very small current. So, by arranging a large number of solar cells in series and parallel way, a considerable amount of voltage like 12 volts or 15 volts can be obtained. Such an arrangement is known as solar panel. You will have seen solar panels. Let's focus our attention here. Solar panels receive sunlight, generates electricity. You can use for the lighting up of the houses. Other applications here: street lamps, rooftops, spacecrafts, satellites. Here, this also shows you examples for the solar panels. This is called the battery. Solar cells produce DC current. We have to use an inverter to convert DC current into AC. Here, other applications: boats. Here, for charging the electric vehicles, we use solar panels. Here, some other vehicles, cars, aeroplanes, calculators. Here, excess electricity can be credited to the national grid to gain extra income. That means solar energy is very important. We can use it for our future generations as well as to minimize our wastage, and we can supply the excess amount of electricity to the national grid to gain an extra income. My dear children, this is the end of our second lesson. Then you can remember, today we learn about half wave rectification, full wave rectification, smoothing, LEDs or light emitting diodes. After that, applications of diodes, solar cells, and applications of solar panels. I am going to teach you another important lesson, transistors, in coming programs. So please refer to textbooks and refer to the past paper questions and enhance your knowledge. You can watch this program again through channel NIE YouTube. Have a nice day.